is Erica Cosmerl, and I am a PhD student in Dr. Jimenez's lab. In this short video of the Brewster dairy pilot plant, we are going to show you a number of pieces of equipment in the pilot plant, as well as talk about the capabilities we have and who utilizes them. Our goal is to give you a virtual tour of the pilot plant so that you can understand our capabilities. We think you will also find it useful in our conversations about the future of the dairy program at The Ohio State University. This is a panoramic view of the pilot plant. There has been a number of pieces of equipment that have been added to the pilot plant over the last few years, which, along with our efforts to become FDA approved, has compelled us to create a new layout. The pilot plant is now organized by a raw mixing area and a processing area. And while you will note that some of the equipment is too large to move and therefore stationary to the pilot plant, a large number of our pieces are mobile and allow us to continuously create arrangements that enhance the students' hands-on learning experience, as well as create an optimal research or industry client experience. Today, we'll show you several different pieces of equipment, including our separator, pasteurization system, GEA membrane system, ice cream freezers, spray dryer, automated cheese vats, evaporator, butter churn, and CIP fouling system. This is the SPX separator, and the first piece I will be showing you from the area that houses the raw blending and mixing equipment. The separator is a relatively new piece to the pilot plant and has been here since 2019. This separator has a flow rate of up to 40 gallons per minute. In addition, we have received quotes and will be placing an order for a rotary low positive pump, which will feed the separator, allowing it to be food grade. Additional upgrades include updating smaller auxiliary pieces to the separator so that the pilot plant can be compliant with the FDA and ODA. This piece is used in faculty and graduate student research, as well as numerous class demonstrations. This HTST pasteurizer, skid, and homogenizer allows for processing of milk, dairy, and non-dairy products, including frozen dessert mixes, non-dairy beverages, yogurt mixes, and juices. This generous donation to the department took place in 2017 and was spearheaded by Beth Cluse at OCS Process Systems with gifts from Rockwell Automation, Pentair, AGC Heat Transfer, Anderson Nagley, Fristam Pumps, Industrial Automation, and Tetra Pak. It has been inspected by the ODA, and both the HTST and the homogenizer have passed state inspection. With regards to the homogenizer, there are some plans for this piece in the near future that include adding new seals. With regards to licensure of the pilot plant for sale of product, at this point, the application has been drawn up, the department's fiscal officer is generating the application fee, and we will submit for approval. Once inspected, we will work to correct any outstanding issues. This equipment has been used for FDA training courses in addition to a number of industry training courses. This equipment has been vital in many of our department courses as we have been able to run product through, and students in the dairy processing lab class have compared the microbial load of raw versus pasteurized milk on Petri films, replicating what would take place in an industry setting, thereby giving them invaluable hands-on experience. As we move to the processing area of the pilot plant, I want to share the GEA membrane filtration system. This system was acquired by the pilot plant in 2019. There has been a lot of research with Cheese Whey on this system so far. Unfortunately, there was only one opportunity for an external client research trial before the shutdown due to COVID-19. This has the capability for both reverse osmosis with ceramic membranes as well as ultrafiltration with spiral-bound membranes. We are now moving to the area of the pilot plant that houses the various ice cream freezers. Capabilities of this equipment include a 1-gallon batch ice cream freezer, 2.5-gallon batch ice cream freezer, and of course, the soft serve machine. A new to us piece of equipment is this continuous ice cream freezer that gives you about a 12 to 15% overrun. This piece was recently donated to us by an industry client who used the equipment in the pilot plant for over 1.5 years to conduct product development. The pilot plant also houses a larger continuous ice cream freezer that has been in service to the dairy program at Ohio State for over 40 years. This piece has also been used for industry client product development work. As stated earlier, much of this equipment is mobile, which gives us the opportunity to maximize student engagement and hands-on learning during lab classes that are conducted in the pilot plant, in addition to meeting the needs of external clients and faculty researchers. Our spray dryer has been in the pilot plant for approximately 3 years and was acquired by Dr. Jimenez Flores to enhance the department's dairy program capabilities. This piece is being used widely for many dairy and blended applications. With this piece, we have had the opportunity for a number of industry client engagements as well as use in our FDA courses and other industry training courses. This equipment has been very effective in demonstrations to students enrolled in our processing courses. We have even extended use to include processing classes from the Department of Food, Agricultural, and Biological Engineering within our college. The spray dryer has been instrumental in providing a realistic industry-type experience for students. This rising film evaporator is another piece of equipment that Dr. Jimenez acquired for the pilot plant. While the equipment is smaller scale, it does allow for large quantities by providing a place to connect a feed pump for continuous flow evaporation. So far, we have performed a lot of batch evaporation. This is another piece of equipment that gets a lot of use in our industry training courses and our FDA courses. Up next is the area that houses our automated cheese vats. In addition to outside client projects, these cheese vats have been used for student engagement in lab class. In addition, there are cabinets that store our cheese processing tools and equipment. This area includes 5-gallon and 50-gallon cheese vats. The number of vats allows for the lab classes to do 3 different types of cheeses simultaneously and spaciously in a comfortable setting that complements the learning atmosphere for the students. In fact, these cheese vats are the original cheese vats used by researchers in the original dairy pilot plant in Vivian Hall. This piece of stationary equipment is a butter churn and is one of the first pieces Dr. Jimenez brought to the pilot plant as the endowed chair of dairy foods. As the only university to have a continuous butter churn, we utilize a variable speed pump that we can feed into the back of the butter churn. The churn then separates the butter from the buttermilk. The buttermilk is then used for various research projects with industry partners in the Jimenez lab. The vacuum system affiliated with this churn allows for us to take off volatiles. We also have the ability to inject an essence or flavor into the product. For example, you could inject a saltwater solution if you wanted salted butter. We also use a clean out-of-place tank as an ice bath for chilling the water that goes into the butter churn. This cooling tank is a piece of equipment that came to us from the former Vivian Hall location and still serves a purpose. With additional hands-on experience manually making butter, the students have a deep appreciation for this continuous butter churn. The final piece that I want to show you is the CIP fouling system. This small-scale HTST and UHT unit came to us in 2019. The funding for this system includes donations from instrumentation sponsors, Emerson and Balmer, donations from Fabricator, Electrol Specialties Company, funds from the Dale A. Cyberling Lab, and funding from the Center for Applied Processing and Packaging Studies. It is specifically designed to study fouling and cleaning, or clean in place. It has over 20 data logging devices that can be used to monitor fouling and cleaning in real time. Outputs from these devices include pressure, temperature, electrical conductivity, pH, electrical heater power, and flow rate. This system also has the flexibility to accommodate different heat exchanger geometries and variable hold tube lengths. Our newest project with the system focuses on ultra-high temperature fouling and cleaning of plant-based beverages.